Dear student, Assalamu alaikum. Class 9, subject physics, chapter number 7. The name of the chapter we are doing properties of matter. Topic of today's lecture is MCQs. We will do MCQs today and problem. We will try to solve 7.1 to 7.4. Pages covered 164, 165, and 166. I repeat, class 9, subject physics, chapter number 7, properties of matter. We are doing topic of today's lectures will be MCQs we will do of chapter number 7, and we will try to do problem 7.1 to 7.4, and pages covered 164, 165, 166. Please open page number 164 of ninth class textbook. We are going to solve MCQs. Please open page 164. This is a chapter we are doing, unit number 7, properties of matter. The name of the chapter is properties of matter. As we have finished this chapter, now we are going to solve uh, MCQs of the MCQs related to this chapter. Okay. Unit number 7 we are doing. So first of all, I'm going to please open page number 164 of your ninth class textbook and circle the correct answer from the given choices. Please mark this down on your book. I'm going to solve the MCQs. Page number 164. Please open page number 164. In which of the following state molecules do not leave their position? A choice is solid, B choice is liquid, C choice is gas, and D choice is plasma. Our right answer is A choice, which is solid. You know, when we studied the topic, the matters, three states of matter, which is four state of matter, plasma is the fourth state of matter, and we studied about solid. The molecules of the solid are tightly packed, so they do not leave their position. So A choice is the right one. So first MCQs, choice A is the right one, which is a solid. Second MCQ is which of the substance is the lightest one? I repeat, which of the substance is the lightest one? A choice is copper, B is mercury, C is aluminium, and D is lead. So if you look at the of this MCQs, my C choice is the right one because aluminium is the lightest one from these four. A is choice is copper, B choice is mercury, C choice is aluminium, and D choice is lead. So my choice C is the right one. So please mark down aluminium is the lightest one from these four. Third MCQ is SI unit of pressure is Pascal, which is equals to A choice is 10 raised to the power 4 Newton per meter square. B choice is 1 Newton per meter square. C choice is 10 raised to the power 2 Newton per meter square. And D choice is 10 raised to the power 3 Newton per meter square. My B choice is the right one. 1 Newton per meter square is the right choice. Please mark down MCQs 3. B is the right choice. B, which is 1 Newton per meter square, is the right choice. Now I am moving towards MCQs 4. What should be the approximate length of a glass tube to construct a water barometer? I repeat, MCQs 4, which is on page number 164. If some students do not open page number 164, please open page number 164. MCQs I'm going to solve is just fourth one. I'm going to read for you. What should be the approximate length of a glass tube to construct a water barometer? A choice is 0.5 meter, B is 1 meter, C is 2.5 meter, and D is 11 meter. When we read the topic, because we use the mercury for the to construct the barometer, but if we want to use the water barometer, we require a length 11 meter, which is the right answer. D is the 11 meter is my right answer. Please mark down MCQs 4. Choice D is the right one, which is 11 meter. Fifth one is according to Archimedes, upthrust is equal to, I repeat, according to Archimedes, upthrust is equal to A choice is weight of displaced liquid, B choice is volume of displaced liquid, C mass of displaced liquid, and D is none of these. My A choice is the right one, which is weight of displaced liquid. A choice is the right one, weight of displaced liquid. First choice one. Please mark down fifth MCQs. A choice is the right one. Sixth MCQs is the density of a substance can be found with the help of. A choice is Pascal's law. B choice is Hooke's law. C is Archimedes principle, and D is principle of flotation. I repeat MCQ 6, which is on page number 164. If some students do not open page number 164, please open page number 164. I am on MCQ 6. The density of a substance can be found with the help of A. Pascal's law, B. Hooke's law, C. Archimedes principle, D. Principle of flotation. My right answer is C. Archimedes principle is the right choice. Now I am moving towards seventh MCQs, which is according to Hooke's law, A choice is stress multiplied by strain equals to constant. B choice is stress over strain equals to constant. C is strain over stress equals to constant. And D equals stress equals to strain. So according to Hooke's law, when we read the Hooke's law, please, because stress is directly proportional to strain, and stress equals to K times constant times strain. So you want to find out the constant. So in this numerical, the B choice is stress over strain equals to constant is the right answer. I repeat, seventh MCQs, the right choice is B, which is stress over strain equals to constant. Now, the eighth MCQs is regarding the diagrams. The following force extension graph of a string are drawn on the same scale. Answer the questions given below from 8 to 10. So in this MCQs, we were given four diagrams. Please note down four diagrams. So which graph does not obey Hooke's law? Because you can see from the graph, C choice is the right one, because when we Hooke's law states that stress is directly proportional to strain, but in C graph we find if we increase the stress, there will be no effect on the extension, there will be no effect on the strain. So C is the right choice for MCQs 8. C is, please mark down choice C of MCQs 8. Ninth, which graph gives the smallest value of given constant? Which graph gives the smallest value of spring constant? I'm on MCQs 9. Which graph gives the smallest value of spring constant? My D choice is the right one. Please mark down choice D is the right one. And the last MCQs, which is 10, which graph gives the largest value of spring constant? A choice B, C, D. My A figure is the right answer. I repeat, 8 MCQs choice is C, and ninth MCQ's choice is D, and 10th MCQ's choice is A. Please mark down these choices. So this is the end of the MCQs, which was on page number 164. Now I'm moving towards problems. Please look at the screen share. This is the chapter we are doing, unit number 7. So we have finished the chapter. So now I'm going to solve problems 7.1 to 7.4. Our problem 7.1, please open page number 165 for problem 7.1. Please open page number 165. These problems are on page number 165. Please open, student. Problem 7.1. I read the problem 7.1 first for you. A wooden block measuring 40 centimeter multiplied by 10 centimeter multiplied by 5 centimeter has a mass 850 gram. Find the density of wood. Problem 7.1. A wooden block measuring 40 by 10 by 5 has a mass 850 gram. Find the density of the wood. So first of all, I write the given data, and the given data is measurement of wooden block is 40 times 10 multiplied by 5 centimeter. Since you know the volume, unit of volume is cubic meter, so that's why I need to convert them, each of them, into meter. So centimeter into meter. So centi is 10 to the power minus 2. If we divide this 40 divided by 100, 10 divided by 100, and 5 divided by 100. I am converting all of these because in volume we have three lengths, length, breadth, and height. So in this case, I am converting each of it 40 centimeter into meter, 10 centimeter into meter, and 5 centimeter into meter. How can I divide this? How can I convert this? 40 divided by 100, it is converted into meter. Then 10 divided by 100, it is converted into meter. 5 centimeter is converted, if it divided by 100, it is converted into meter. So 40 divided by 100 is 0.4, 10 divided by 100 is 0.1, 5 divided by 100 is 0.05. If you multiply with the help of calculator, 0.4 multiplied by 0.1 multiplied by 0.05, you will get 0.002 cubic meter, which is the unit of volume, which is the SI unit of the volume. System International, SI unit of the volume is cubic meter. So we have converted centimeter cube into meter cube. Volume unit is 0.002 cubic meter. We have converted into SI unit because the SI unit of volume is cubic meter. Mass is also given to me, which is M, where it is noted with small m, and it is given to 850 gram. And you know the SI unit of mass is kilogram. So in that's why I'm going to convert this grams into kilograms by dividing it with 1000. 850 divided by 1000, I will get 0.85 kilogram, which is the standard SI unit of the mass. So student, first of all, I converted volume into cubic meter because it was not the centimeter is not the centimeter cube is not the SI unit. So I converted this into meter cube because the standard SI unit of the volume is meter cube. Similarly, I convert mass. Mass unit was given to me in grams, so I converted this into kilograms because the SI unit of the mass is kilogram by dividing it 1000. So 850 divided by 1000, I will get 0.85 kilograms. In this numerical, I am asked to find density, and density is denoted with rho. This is the rho letter. Density is denoted with rho. So density formula is mass per unit volume. When we studied the chapter, under the topic density, I told you the formula for density is mass per unit volume. Mass per unit volume. You got to remember this. We are going to use so many times. In so many numericals, we are going to use this formula. Density is equal to mass per unit volume. So mass is noted with small m, and volume is noted with V, and density is noted with rho, sometimes D, but in this case, I'm noting this with rho. So what is mass given to me? Mass is given to me 0.85 divided by volume. I just found 0.002. If you divide 0.85 divided by 0.002, you will get 425 kilogram per cubic meter. Because the unit of mass is kilogram and the volume is cubic meter, if you shift plus 3 on the top, it will be minus 3. So the density found to be 425 kilogram per cubic meter. So our result will be density is rho 425. I just found 425 kilogram per cubic meter. Now I am moving towards numerical 7.2. Numerical problem 7.2. First of all, I read the statement of the numerical 7.2. What should be the volume of ice formed by freezing 1 liter of water? I repeat, what should be the volume of ice formed by freezing 1 liter of water? This numerical is on page number 165. Please open page 165. I am going to solve problem 7.2. What would be the volume of ice formed by freezing 1 liter of water? First of all, I write the given data. Volume of the water is given to me 1 liter, and density of ice, you should know, you can look in the table. Density is 920 kilogram. You can, if you open page number, if you open page number 147, you can find the density of ice is given to me 920 kilogram per cubic meter, which is on page number 147. You can look the table on page number 147 under density of various substances. So density of ice is 920 kilogram per cubic meter is given to me. You need to find out from the table. Okay, but to find in this numerical, we are asked to find volume of ice. So solution formula is volume of ice divided by volume of water equals to density of water divided by density of ice. I repeat, volume of ice divided by volume of water equals to density of water divided by density of ice. Since I want to find out volume of ice, so density volume of water will be multiplied. If it is go on the other side, it is dividing. If it is go on the other side of the equation, it will be multiplied. So you separate out volume of ice. So just plug in the values. Density of water. You should know the density of water is also on page number 147 under table 7.1. Density of various substances. You can also check the density of water is also available on page 147 under the table 7.1. The name of the table is density of various substances. Okay. Density of water is also known to me, which is 1000 and density of ice is 920 and volume of water is 1. Volume of water is 1. If you divide this 1000 divided by 920, you will get 1.09 liter, which is the required answer. I repeat, this numerical problems, problem 7.2 for you. First of all, I read the statement for you. In the statement, it says, what should be the volume of ice formed by freezing 1 liter of water? So volume of water is 1 liter given to me, and density of ice I found from the table on 147 page under table 7.1. Please look at the table 7.1. From the table, I note this down. Density of ice is 920 kilogram per cubic meter. And you should also know density of water is also given on the table 147, page number 147, table 7.1. Please note 147, look at the table 147, page number 147. Density of water is also given to me 1000 kilogram per cubic meter. So the formula is volume of ice divided by volume of water equals to density of water divided by density of ice. If you, because you want to separate this out, if it is multiplying, if it is dividing here, if it is on the other side of the equation, it will be multiplied. So density of water divided by density of ice multiplied by volume water. Density of water is, you should know, you can look at the table 147, the page number 147, table 7.1. You can find the density of water from there, which is 1000, and the density of ice is also from the table. I noted this from the table 920 multiplied by volume of water is given to me, which is 1 liter. So my result will be volume of ice is 1.09 liter. Now I'm moving towards numerical 7.3. I read the numerical statement first for you. Calculate the volume of the following objects. In this numerical, we are asked to find out the volume of the object. The first 7.3 is an iron sphere of mass 5 kilogram The density of iron is 8200 kilogram per cubic meter. First of all, I write the given data. For 7.3, I'm going to solve problem 7.3, first one, because 7.3 problem has three parts, 1, 2, 3. So I'm solving part 1 of 7.3, or which is on page number 165. So first of all, I write the given data. Mass of iron sphere is m, which is 5 kilogram, and density of iron sphere is also given to me, which is 8200 kilogram per cubic meter. In this numerical, we are asked calculate the volume of the following objects. The volume of iron sphere we want to find out, and volume is not with V. So our formula for density, I told you when we studied the density topic, I told you the formula for density is equal to mass per unit volume. So in this numerical, we want to find out the volume. So shift this volume on this side and density at the bottom. So mass divided by density is the volume. Because I'm cross multiplying separate out volume from this formula. So volume formula will be m over g, mass per density. So mass is 5 and density is given to me 8200. Mass is given to me 5 kilogram and density is 8200. Just plug in these values and solve this 5 divided by 8200. When you divide this, you will get the volume 6.09 into 10 to the power minus 4. And the unit of volume, standard SI unit of the volume is cubic meter. So if you round off this figure up to 2 digits, up to 1 digits after the point, 6.1 into 10 to the power, because 9 is greater than 5. So that's why 1 will be here, 6.1 into 10 to the power minus 4 cubic meter, which is the required answer. So our result will be volume. Volume is equal to 6.1 into 10 to the power minus 4 cubic meter. Students, this is a straightforward MCQ numerical. So just use this formula and whatever you want to find out, just separate out that one. So in the next problem 7.3, which is I'm going to solve part 2 now of this problem. I read the statement first. 200 gram of lead shot having density 11,300 kilogram per cubic meter. I repeat, 200 gram of lead shot having density 11,300 kilogram per cubic meter. Mass of lead shot is given to me m small, do not be mass of anything is going to be small m. So in this case, mass of lead shot is m small m, which is 200 gram. This is not the standard unit. This is not the SI unit. That's why I converted this into kilogram, because the SI unit of the mass is kilogram. How I converted this? By dividing this 1000. 200 divided by 1000, it will be 0.2 kilogram. I converted mass into kilogram as we usually do. Density of lead is also given to me, and density is not with G. 11,300 kilogram per cubic meter is the unit of density, kilogram per cubic meter. These two things are given to me. So in this numerical, I am asked to find volume of lead, and volume of lead is not with B. Same formula I use in the part 1, 7.3 part 1. Same formula I will use here. V m over D. M is 0.2. M is 0.2 and density is 11,300. I just plug in the values and I solve this with the help of calculator. 0.2 divided by 11,300. You will get 1.77 into 10 to the power minus 5 cubic meter is the unit of the volume. So my result will be volume 1.77 into 10 to the power minus 5 cubic meter. Now I'm moving towards numerical, same numerical problem 7.3, but now this time I'm going to solve part 3 of 7.3, problem 7.3, part 3. I read the numerical statement for you first. A gold bar of mass 0.2 kilogram. The density of gold is 19,300 kilogram per cubic meter. I repeat, 3 MC part. I'm solving problem 7.3 part 3, which is on page number 166. Please open page number 166 to find this numerical. A gold bar of mass 0.2 kilogram. The density of gold is 19,300 kilogram per cubic meter. So in this case, I want to find out the volume. Same formula I will use, which I used in the other two parts. volume is equal to, so 0.2 is mass. This is already in kilograms, so we don't need to convert this into kilogram. This is already in standard. The mass unit is 0.2 kilogram. This is also already in standard SI unit. We don't need to convert this. So density is 19,300 kilogram per cubic meter. So this is also in SI unit. So density unit is kilogram per cubic meter. So in this numerical, we are asked to find the volume of the gold rod, which is not with V. I will use the same formula which I use with other two parts. So V is equal to M by D. So just plugging the values, mass is 0.2 and the density is 19,300. If you solve this with the help of calculator, you will get 0.00000104. If you convert this into scientific notation, so your answer will be is how many digits I'm moving. I'm moving 5 digits from left to right. So if I'm moving from left to right, the power will be negative. 1, 2, 3, 4, 5. Because I want to convert this point after 1. So I'm moving 5 digits from here to here, left to right. So 1.04 into 10 power minus 5. So this is a scientific notation. I have converted this 1.054 into 10 power minus 5 cubic meter. This is the required answer for this problem 7.3, part 3. Now I'm moving towards numerical 7.4. And the numerical 7.4 is the density of air is 1.3. I'm going to read the statement of numerical 7.4, which is on page number 166. Please open page number 166 to find this problem. 7.4. The density of air is 1.3 kilogram per cubic meter. Find the mass of air in a room measuring 8 meter by 5 meter by 4 meter. So first of all, I write the given data, and the given data is density of air is denoted with rho, and rho is given to me 1.3 kilogram per cubic meter. This is standard in standard unit. We don't need to convert this. We it will remain as it is. Volume is denoted with V, and 8 meter, 5 meter by 4 meter. This is also given to me. If you multiply this, 8 multiplied with 5, 5 multiplied with 4, you will get 160. And the unit meter, meter, meter. So 3 meter, when the base is the same, power will be added. So meter cubic, cubic meter is the unit of volume. Mass of air in a room we need to find out. So I will use the same formula as I used in my last numericals. I will use the same formula. Density formula is mass per unit volume. Since we want to find out the mass, so density will be multiplied. Density is equal to rho. When you have light things, so density will be denoted with rho. When you have a denser things, the density is denoted with small capital D or small d. But in this case, since a density of air is the lightest, so that's why rho is noted for density. Don't get confused with rho or d because they are the same things, but for the small or the lightest things, we take it as rho, and for the heavier things, we use d, small d or capital D. Or mass of the air in room is mass m. D is equal to m by m is the mass per unit volume. So I use D is replaced with rho because density of air is rho. So cross multiply. So separate out m and just plug in the values. Volume is 1.3, 160, sorry, and rho is 1.3. If you multiply 160 with 1.3, you are gonna get 208, and the unit of mass is SI unit of mass is kilogram. So my result will be mass m is equal to 208 kilogram. So this is the end of the today's numerical 7.1 to 7.4. So your homework is practice MCQs and solve problems 7.1 to 7.4 on rough registers. First of all, you need to practice it on the rough registers and transfer them on a leaf register once each. Yani first of all, you will do 7.1 to 7.4 on the rough registers, and when you feel yourself you are comfortable solving MCQs 7.1 to 7.4 by yourself without looking, and then you transfer them on the leaf registers. And this why I'm saying on the rough registers, because they will practice makes a man perfect. So you need to make the make them practice a lot uh, to be adept in your numericals problem 7.1 to 7.4. And then when you are adept in solving these type of problems and MCQs, so try to uh, transfer them on the needs registers. So this is the end of the today's lectures. If you have any questions regarding uh, today's lecture, please feel free to ask questions. I'm here to answer your questions. Thank you. Anyone has any question? Mehrunisa, Rabia, Usman, Yunus, Muzna, please feel free to ask questions. If you want me to repeat the numerical for you, please ask me, tell me, I will repeat for you. If you have any questions, if you have any question about MCQ's point of view, I'm ready to answer your question. Please unmute your mic and ask questions. Muzna, Rabia, any questions? Rabia, Muzna, please ask question if you have any problem regarding today's lecture. If you don't understand any part of the problems or you have problem in MCQs, please feel free to ask question.